Hi, welcome back to my channel. Well, in this video we'll try to learn some of the important probability distributions. So we'll try to learn some of the basic fundamentals about probability distributions. What are random variables, what are different types of random variables, what is distribution function, and what are some of the important probability distributions which are commonly used, like binomial, Poisson, and normal distributions. So let us begin. The concept of probability distribution is similar to frequency distribution. Just as frequency distribution tells us how the total frequency is distributed among different values of a variable, similarly the probability distribution tells us how the total probability of one is distributed among various values which a random variable can take. So there are two important things. One is variable and another one is random variable. So these are two different things. A variable is a measured characteristics that can vary in degree or extent, or it can take any value and it varies from one individual to another. But a random variable is something different. It is a function which takes real values and which are determined by the outcomes of a random experiment. And if we will take an example of tossing of a coin or rolling of a die, these are the best examples of a random variable or random experiment, because in tossing of a coin we know what are the outcomes, but exact output we can't be sure at the time of tossing. We know either head will appear or tail will appear, but at the time of tossing we are not sure whether head will appear or tail will appear. So in case of random experiments we know what are the outcomes, but exact output can't be known in advance. So that is a classical example of a random experiment. So as far as the collection of information is concerned, if we recall the previous video about measures of tendency and measures of dispersion, we get an idea about a center of a gravity of a distribution or a series by means of measures of tendency, and how much these rest of the values deviate from the center. We can get that idea by means of measures of dispersion. But the big question that arises is that how data points or the values of a particular variable or a random variable are spread across the range of that variable. So for that we need to know about the spread, how these values, how and where these data points or the values of a variable are spread across the range of variable. For that, distributions play a very important role. So a distribution refers to the way values are spread or distributed across different outcomes in a set of data. It describes the likelihood or probability of observing each possible outcome. In statistical sciences and in case of theory of probability or probability theory, distributions are usually represented graphically by means of some of the important functions which are known as probability distribution. There are different types of distribution, and every distribution has got its own characteristics, has got its own pattern. So understanding of this distribution, or we can say the understanding the distribution of a data, is very crucial for statistical analysis, for decision making, and for making predictions about the future observations. So the question now is, what are these probability distribution functions? Because they are the basis, or they are the foundation, they are the pillars for this distribution. Now what is a distribution function? A function f of x of a random variable x for a real value of small x giving the probability of an event is called a distribution function, or we can write it mathematically in this form, or we can say it gives us an idea about the probabilistic behavior of a random variable across its range at each point. Now when we talk about random variables, we have two different categories. One is discrete random variable and another one is continuous random variable. Both are real valued functions, but this discrete random variable is defined on a discrete sample space. That means it can assume countable number of real values, but continuous random variable, it is defined on a continuous sample space, and it can assume all possible values like fractional, decimal, integral, anything. But what about the probabilistic behavior of discrete random variable and continuous random variable? The probabilistic behavior of discrete and random variable are defined by means of a function that is known as, one is known as probability mass function and another one is known as probability density function. So a function f of x or p of x is said to be a probability mass function for a discrete random variable if it satisfies the following properties. Similarly, a function f of x in a similar way is said to be a density function for a continuous random variable if it satisfies the properties which are given here. So we can say the probabilistic behavior of a discrete random variable is defined by a function which is known as probability mass function, and the probabilistic behavior of a continuous random variable is defined by a distribution function that is known as probability density function. So we can say in a nutshell there are two types of functions or distribution function. One is meant for discrete random variables and another one is meant for continuous variables. So both of these distribution functions gives us an idea about the probabilistic behavior of that particular variable. So if they satisfy these properties, then we can say they are actually the distribution functions of that particular variable. So in case of discrete, you will always find this summation, and in case of continuous random variable, you will always find this integral. So it is very easy to remember, whenever you have a summation, it is discrete, and whenever you have an integral value, it is continuous in nature. That is, integral of f of x d of x is equal to 1 and function of x is greater than or equal to 0. Similarly, you can convert them in terms of probabilities. Then a very important concept that is known as mathematical expectation, which is nothing, it's an average of a random phenomena, or we can say the expected value of a random variable is a weighted average of all possible values of a random variable, where weights are nothing, these are the probabilities associated with the corresponding variable. So in case of discrete, again we have a summation, and in case of continuous, like I've said in the previous slide, we can take the integral value. So expected value of a discrete random variable, it takes this form, and in terms of continuous, we have an integral form. Now there are different types of probability distribution. One category is a discrete probability distribution and another one is continuous probability distribution. So whenever we are having variables which are discrete in nature, or we can say when the sample space is discrete or when the sample space is continuous. Under discrete distribution, we have different types of distribution: discrete uniform, binomial, hypergeometric, negative binomial, geometric, and Poisson distribution. And in case of continuous, again we have a uniform, normal or Gaussian, gamma, beta, t, f, and chi-square distribution. But in this video, we'll try to focus on binomial, Poisson in case of discrete probability distribution, and in case of continuous, we'll discuss about the normal distribution. Again, I will repeat it that discrete distributions are meant for when we are dealing with discrete random variable. That means when the sample space is discrete, and when the sample space is continuous, then we are dealing with the continuous probability distribution. Now the first discrete distribution is a binomial distribution. It was given by James Bernoulli in 1700, and it is based on the Bernoulli's trials. So as far as this Bernoulli's trials is concerned, if a random experiment whose the outcomes are of two types, basically this is usually meant for those kinds of experiment when we are having only two outcomes, like present, absent, dead, alive. Okay, those kinds of experiments, this binomial distribution is used. So its base is based on, or we can say the foundation of this binomial distribution is based on Bernoulli's trial. Now what is this Bernoulli's trial? So if a random experiment whose outcomes are of two types, say for example success or failure, occurring with some probability, say P and Q, because P is defined for success and Q for failure respectively. Such trials or such random experiments are known as Bernoulli's trials. And if for this experiment a random variable is defined such that it takes a value of 1 when success occurs, and it takes a value of 0 if failure occurs, such kind of distributions are known as Bernoulli's distribution. But as far as these binomial distribution concerned, if we have a discrete random variable, so we can simply say if we have a discrete random variable, or we can say a random variable or a discrete random variable is said to follow a binomial distribution if it assumes non-negative values and its probability mass function is given in this form, where P and N, these are the two parameters, or N we can say the degree of binomial distribution. Since this binomial distribution is discrete distribution, and it can take only finite numbers of trials, we can say the conditions for this binomial distribution is that the number of trials is not we can say each trial results into two exhaustive events, or we can say each trial results in two types of mutually exclusive or disjoint events outcomes, which are known as success and failure, that is P and Q. The number of trials, which is N in this case, they are finite, they are not infinite, and the probability of success, that is P, it is always constant for each trial, and the trials are independent of each other. So these are some of the conditions which are required for this binomial distribution, and the base of this binomial distribution is based on the Bernoulli's trial. So we can say X successes out of N Bernoulli's trial, and this kind of distribution is usually used whenever we are dealing with a situation or we have a experiment where we have only two possible outcomes, say success or failure, say present or absent, male, female, dead or alive. So those kinds of experiments, so we are dealing with binomial distribution. In binomial distribution, the mean is NP and the variance is NPQ. So that means the we have a mean which is always greater than variance in case of binomial distribution, or we can say that vice versa, variance of a binomial distribution is always less than a mean. And the condition is that the number of trials they are finite, the probability of success remains constant for each trial, the number of trials we can say N, they are finite, and each trial results in two exhaustive and mutually disjoint outcomes, that is known as success or failure. Another very important discrete distribution is known as Poisson distribution. It was given by Simon Dennis Poisson 1837, and it is usually meant for those kinds of events which are rarely existing, or we can say the events occurring in the fixed interval of time. The rare situations are like the number of air accidents, volcanic eruptions, earthquakes. So we can say a random variable X, or we can say a discrete random variable X is said to follow a Poisson distribution if its probability mass function, since it is a discrete distribution, so if its probability mass function is given in this form, that is e raised power minus lambda raised to the power x divided by x factorial, where this lambda is a positive real number, or we can say this is a parameter of this Poisson distribution. This lambda is always equal to n into p, where n are the number of trials and p the we can say the probability of success, and this lambda is a parameter, and the ppm is always in this form, and this whole term it is known as Stirling's approximation, and this x it should always be a non-negative integer, or it is a non-negative integer, or we can say this Poisson distribution is a limiting case of binomial distribution because of the fact we have two conditions. That means the number of trials they are indefinitely large, that means n tends to infinity, and the constant probability of success for each trials is indefinitely small or very small. But in case of binomial distribution, the probability of this success is usually constant for each trial, and the number of trials are very finite, so that is why it is a limiting case of binomial distribution. Now moving ahead, we have a very important distribution, or we can say the most frequently occurring distribution in the universe, and almost all the variables which are real existing, because existence of the real events, when we talk about the existence of real events, we are talking about a normal distribution. So normal distribution, it was way given by De Morey, was the pioneer in 1733, and in fact some say the Laplace has also given the contribution to the normal distribution, but Carl Friedrich Gauss is assumed to be a pioneer in case of this normal distribution. That is why this distribution is sometimes known as Gaussian distribution. Now mathematically or statistically, how we can define a normal distribution, which is a continuous distribution. So if we will take an example of this x, which is a random variable, we can say if a random variable x has got a mean mu and standard deviation sigma, then we can say it follows a normal distribution if its probability density function is given in this form, that is 1 upon under root 2 pi e raised power minus 1 upon 2 sigma x minus mu, where this pi is nothing, it is 22 divided by 7 or 3.14, do you know it, and under root of 2 pi is always equal to 2.50, and this e is usually the base of the system of natural logarithms, usually 2.7, and this x range from minus infinity to plus infinity. And there is another important concept in normal distribution, that is known as standard normal distribution. So we can say a random variable x, or we can say x is a random variable following a normal distribution with the mean mu and standard deviation sigma. Then we can say a random variable if it follows this form, because here the z is equal to x minus mu by sigma. If we replace this in this equation, then it will come out like this, that is 1 upon sigma under root 2 pi e raised power minus 1 upon 2 z square, and it follows a normal distribution with mean 0 and standard deviation 1. Mean 0 or a constant variance we can say, because this plays a very important role in testing of hypothesis. And in case of parametric statistics, we always say the data which is taken from the sample, it must follow the normal distribution, because when we will start the lectures of testing of hypothesis, the role of normal distribution plays a significant role in those situations. So we have two parameters, mu and sigma, it is 0 and it is 1. So in terms of expectation, we can prove it out, because expectation of a constant is always equal to constant, and the variance of x of a random variable is also sigma square, and variance of mean is sigma square by n. And if we will substitute these values here, because this constant, because this expectation of a constant always equal to constant, so that is why it will get out to 0, that is mu minus mu is always equal to 0, 0 by sigma is equal to 0, so the expected value is equal to 0, or we can say the mean, because expected value is nothing, the average of a random phenomena. And in terms of variances in context of in context of mathematical expectation, we will get out, we will substitute these values here, then we will get it out like this. Is very simple, this is the simple arithmetics, plus minus and nothing. But here you have to remember this thing, that the variance is independent of change of origin. That is why this term gets cancelled, or we can say this whole thing mu becomes 0. Then it becomes 1 by sigma square into variance of x, and variance of x is always equal to 0, sigma square, sorry, then sigma square divided by sigma square is equal to 1. So mathematically this is the way how we can prove that the standard normal variate follows a normal distribution with 0 mean and constant variance or standard deviation. Now this was all about the interpretation of normal distribution mathematically, but statistically, mathematically or statistically, but how we can identify a particular distribution is following or is having a kind of a distribution, or we can say a particular distribution follows a normal distribution. For that, the first thing is, if we are having a bell-shaped curve, then we can say it's a normal distribution. Or we can say if a curve is symmetrical, that means mean, median and mode, if they coincide here, then we can say there's a clear evidence that it follows a normal distribution. And if the total area is equal to 1, this is one of the properties, that total area under this one. And if we will go back to the previous slide, the x value, this horizontal axis, if you will see, these two tails, they never coincide with this horizontal axis. That's why it changes from -infinity to plus infinity. So the curve is bell-shaped and it is symmetrical at this point. Or we can say the mean, mode, median, they also coincide. As the value of x increases, the function of x decreases, and that is why it is more peaked in the center. And we have two important things here. One is symmetry and another one is kurtosis. The coefficient of skewness here is 0, so it is symmetrical, because symmetry, because there's a very important concept in study. One is skewness and there is kurtosis. Skewness shows us about the symmetry of a curve. If it is 0, then this curve is symmetric, and if the coefficient of kurtosis is equal to 2, it gives us about the peakedness of a curve, and it is mesokurtic, because we have three different types of kurtosis. One is leptokurtic, platykurtic and mesokurtic. And if it is equal to 3, then we can say this distribution follows a normal distribution. And the point of inflection in case of normal distribution is always equal to f of x upon this under root 2 pi e raised power -1/2. So how we can say a distribution is a normal distribution? The one thing is that the normal distribution is a distribution of a real events. So existence of real events, when we talk about existence of real events, we are talking about a normal distribution. So how we can say mathematically or statistically that a distribution is normal? Then for that, if we have a random variable with some parameters, like it has got a mean which is mu, and it has got a standard deviation sigma, then if it takes a form of that under root 2 pi sigma into under root 2 pi, this previous form, then we can say it is it follows a normal distribution. Then if we have these kind of features, then we can say a distribution follows a normal. And we have a very important characteristics here. That means 68% of the observation falls under the first standard deviation. We can simply write mu plus minus first sigma, and this is actually known as 68-95 rule. And 95% of the observation falls under the second standard deviation, mu plus twice sigma. On both sides we used to write it like mu plus minus twice sigma, and 99.7% of observation falls in the range of this mu plus minus 3 sigma. Since normal distribution plays a very significant role in testing of hypothesis, in fact in all parametric statistics it plays a very important role. This normal distribution as a limiting form of binomial distribution with some conditions, that if the number, in case of binomial distribution, if the number of trials are very large and neither the probability of success nor the probability of failure is very small, then in those situations we can say a particular distribution, if we take an example of this binomial distribution or Poisson distribution, then they tends to this distribution, that is normal distribution. So each and every distribution, if we see under some conditions, they used to tend this normal distribution, and this forms the baseline of statistics. And in fact the statistical procedures, they usually assume the data that is taken into the consideration follows a normal distribution. So this distribution is a very important thing. So hope you will like this video. In next video we'll try to learn about testing of hypothesis. Then after that we will start correlation and regression. Thank you very much.